Welcome back to the YouTube channel Arke's Electric World. As in the last two lectures, we have covered the basic concept and electrical units and system measurement under the fundamentals of electrical engineering. In today's lecture, we are going to discuss about the third point under the fundamental of electrical engineering, that is circuit elements and types. So which are the different types of element that used in a electric circuit that we are going to discuss today. So in this lecture we are going to discuss about the different types of element, that is the active versus passive element, linear versus non-linear element, then bilateral and unilateral elements, and then lumped and distributed element. So these different four types of element which is used in electric circuit that we are going to discuss today. Okay, so let's start with the active and passive element. So first we will discuss about the active versus passive element. So what is the active element? What are the examples of that we will discuss. So first one is the active element, which is having the capability of delivering the energy to the circuit. So this active element that is used for delivering the energy to the circuit means that it can generate the electrical energy. So active element can generate the electrical energy. So example of active elements are batteries, voltage sources, current sources. Then what is the passive element? Passive element is nothing but the element which consume or store energy but cannot generate it. It's only store or consume the energy. So example of passive elements are resistor, capacitors and inductor. So this is the active and passive element. So simple difference between the active and passive element is nothing but the active element generate the energy and passive element cannot generate the electric energy. Okay, clear? Then next element that is used is nothing but the linear versus the non-linear element. So first we will discuss about the linear element. So a linear element which follows the Ohm's law. So Ohm's law, follow the Ohm's law means that the voltage is directly proportional to current. And in details about the Ohm's law, what are the limitations, that we will discuss in the DC circuit. Okay, here just remember linear element which follows the Ohm's law means that voltage is directly proportional to current, means that graph between the voltage and current is a straight line. Examples of linear element, that is nothing but the resistor, ideal inductors and capacitor. Please remember the word, that is the ideal inductors and capacitors are the linear element. Okay, practically it is not possible. So how it's not possible, that we'll discuss later on. Just remember this is nothing but the linear elements. Then what is the non-linear element? Non-element that is do not follow the Ohm's law. So it is not following the Ohm's law, that is nothing but the non-linear element, means that the voltage and current relationship is a non-linear, and simply we can also say that non-linear components are those that are changed with respect to the voltage and current. So this element change with respect to the voltage, applied voltage and current. So examples of non-linear element, that is nothing but the diode and transistor. So this is simply the linear element which follows the Ohm's law, and non-linear element do not follow Ohm's law, means that simply relation between the voltage and current. Then next element, that is nothing but the bilateral versus the unilateral element. So first we will discuss about the bilateral elements. Bilateral elements means that allow current to flow equally in both directions. So this bilateral element is nothing but the element, or we can say the component, electrical component, which allows to flow the current equally in both the direction. So electrical properties remain same for the current direction. If current is flowing in one direction or another direction in that particular element, the electrical properties will remain same. It will not change. That is nothing but the bilateral element. So example of bilateral elements, that is nothing but the resistor, capacitors and inductors. So bilateral element, in that the current is flowing equally in a both direction in that particular element, that is the bilateral element. Next I'll discuss about the unilateral element. So unilateral element is nothing but allow current to flow primarily in a one direction. So the properties change with the direction of current. Also this unilateral element an electric circuit is defined as the element whose VI characteristics changes on a reversal of polarity of applied voltage. Means that if the applied voltage polarity will get changed, it will change the VI characteristics also. So it means that the magnitude of current passing through this type of element is affected due to change in the polarity of the applied voltage. So the polarity of that particular current flowing in that particular element, it's changes. That's why this unilateral element that allows to flow the current in only one direction only. So examples of unilateral element, that is nothing but the diodes and transistor. So these basic electronics component are the example of unilateral element. So simply difference between the bilateral and unilateral element is that bilateral element allow current to flow in both the direction, and unilateral elements that allows to flow the current only in one direction. Then last comparison between the elements that is used in electrical circuit, that is nothing but the lumped versus the distributed elements. Okay, so one by one we'll discuss. So first one is the lumped elements. So the example of these lumped elements, that is nothing but the electrical component, that is RLC, means resistor, inductor and capacitor are assumed to be located at the single point. So we are, while analyzing the transmission line, we are considering these three parameters that is assumed at the single point. So this is located at a particular one single point, that's why it's called as the lumped element. So it is used in a low frequency circuit analysis. So example, as you know, that is the resistors, capacitors and inductors. These are the example of lumped elements. And lastly, that is a distributed elements. So distributed elements, that is nothing but the properties are distributed along the physical length of the conductor. So these conductors or these element is distributed along the physical length of that particular conductor. This distributed element is important in a high frequency application and simply in the transmission line. So these are the transmission line and coaxial cables. So these are the examples of the distributed element. So simply lumped means that the element which is assumed to be located at a particular single point in the circuit. So this is the lumped element. And distributed element, that is nothing but the which element distributed along its physical length of that particular conductor. So example of distributed element, that is the transmission line and coaxial cable. So this is all about today's lecture about the circuit element and their types. Thank you. And next lecture, that is the last part from the fundamental of electrical engineering, that is conductors, insulators and semiconductor.